In this video, we will do page number 23 on your handout. And we'll continue working on geometric proof. A geometric proof can be begin with the given and prove statements. And in a two-column proof, we have statements on the left and right-hand side. We have reasons. Example number 1, given statement, segment A, XY. And prove XY itself is congruent to itself, XY. Oh, so where do we begin? Given, right? What's given? Okay, what is given here? Just copy it, right? It means there is a segment named XY, okay? That's the meaning. So we talk about existence, okay? There is XY segment that is given. So I simply copy given statement, okay? And what is the last thing I need to end with? The thing to prove, right? Prove statement. So XY is congruent to itself, like that, right? Make sense? All right, can I say XY same as XY? Oh, we heard about this before when we talk about algebra properties, right? One thing, two things, three things. O, P, Q, R, S, T, U, right? What was the name of the property? Reflexive property, symmetric property, transitive property, right? How many objects do we have? We have two things or one thing? XY same as itself XY, so we are saying one thing, okay? So this is reflexive property of what? Equality. That's why we can say XY is congruent to XY itself, okay? And we will say that is a reflexive property of congruent segment in the future. Make sense? All right, next one. Example number 2, fill in the blanks. Given information, angle 1, angle 2 are supplementary to each other. Another given, angle 2 and angle 3 are supplementary to each other. We are going to prove angle 1 and angle 3 are exactly the same thing, okay? So let's start with the first one. And the reason is given. So what do I need to write? Would you like to write first one and second one? Or both of them? So let's look at what is on the next thing, okay? Step 2. Measure of the angle 1 and measure of the angle 2 is same as 180 degrees. And measure of the angle 2 and measure of the angle 3 is 180 degrees. Are we talking about both of them? Yes, so I need to copy whole thing and I need to put over here, right? Make sense? Yeah, so we start with the given. And the last one, so if I have any questions like this, first thing and the last thing is the easiest one because you know where to begin, where to end. What is the end statement? Right here, right? Got it? Okay, now let's think about next steps in the middle, okay? By knowing that, can I put them together and list all as one thing? And what is the reasoning here? Subtraction or substitution. Oh, that's why I have to write it whole. What would be that? This one, substitution. That would be better because I'm using 180, those same thing, and then I will substitute. Or I can say transitive property. And I prefer saying transitive property here, but okay, that's fine. So I'm going to say left-hand side is same as the left-hand side here, right? What? Okay, so I have left-hand side, and I substitute 180 degrees, okay? So we can equate them. You can say substitution method, or I can say transitive property here. Okay, either way, fine. So you can write answer here in the space, okay? All right, next one, number 4. I can say measure of the angle 2 is same as measure of the angle t by using reflexive property of equality. So if they are same and I can consider removing those two at the same time and I can conclude the left and right hand side like this. What did I do? I subtract, right? So this is subtraction. Subtraction property of equality, and then we have a measure of angle 1 is same as measure of the angle 3, and then I can say angle 1 is congruent to angle 3. When the measures are congruent on angles and two angles are congruent, that's called definition of congruent angles. Okay, so by using definition of congruent angles, you can go to geometry word to algebra word, or you can come back algebra word to geometry word. Notation number 5 and number 6 is different. Number 5, we have equal sign. That means it's algebraic notation. So you must have M in front of it to refer the numbers. Number 6 doesn't have M. That means we are looking at geometry figure itself. So this is in the geometric word, okay? So we are using congruent notation. Never mix them, okay? If we come or go from other notations, so we always use definition of the congruent angles. Or if we are talking about segments, we say definition of congruent segments. Okay? All right, so that was a little tough. If I'm doing it by myself, and I may not use number 4 here, using reflexive property of equality, I may just direct subtracting quickly. That's fine. You can refer it or not, that's fine. If it is good enough to follow the logic to conclude, it is good proof. So here we have some theorems. If you see theorems, we must memorize them, okay? Right angle congruence theorem. Euclid, BC, about 300, 400 years ago. Euclid stated this, all right angles are congruent. So this is actually not a theorem, this is a postulate. So we have nothing to prove it, okay? Postulate. But never mind. Okay, it's from book. So hypothesis will be angle A, angle B are right angles, and conclusion, angle A, angle B are same. Okay, so that is it. And next one, congruent complements theorem. So we talk about this in the other video. Two angles are complementary to the same angle, then two angles are congruent. Okay, so that is obvious things, right? If we have a theorem, we have to prove it. If it is a postulate, we don't need to prove it. Okay, any questions? So let's write definition of congruent angles. What is it? Angle, give me an angle. Angle A is congruent to angle B. And you can say that that is same as measure of the angle A equals to measure of the angle B. Okay, that's the equation. This is congruence. That is definition of congruent angles. Can I say another one? Definition of congruent segments. Give me a segment. AB, segment AB. Give me another segment. CD, okay, good. And I use congruent notation in the middle, okay, to define congruent segments. So that is congruent segments, and it means in geometry, the measure of the length of the segment AB is equal to measure of the segment CD. So second statement is about algebra, numbers. The first one is geometric figure itself. So don't get confused when you choose the notation, okay? Geometry with the congruent sign. Algebra with the equal sign. What is Algebra is the number, measure of the angle. This notation without bar means measure of the segment. Okay, so use the notation carefully. So from here to there or from there to here, we are saying the reasoning must be definition of the congruent angles or segments. So remember that, and we will use those in the proof in the future.